Hey, Katie.
Hi, Phoebe.
So today we're talking about reasoning models, which are the ones that generate that intermediate chain of thought and reasoning about what they're talking about before giving you a final answer.
They do that. I think that's fair. Yeah, they're just, I think I'm really excited for this. I think reasoning models they're capable of much more than you would have guessed, given the primitives that they're built out of. So, yep, we'll talk a little bit about that reasoning trace and how they act a little bit different from kind of your regular traditional LLMs. But I think the really cool story here, though, is that they can just do so much more than fancy autocomplete. So I'm excited to talk about it. Reasoning models.
Yes, large reasoning models no longer your fancy autocomplete. Or are they? You are listening to?
Linear digressions.
I just said, or are they, because it seemed more suspenseful, but I guess we'll talk about that.
Yeah, and I primed you a little bit. We'll get there. We'll get there. It's interesting because they're different and they're not. Reasoning models, let's see, they're not exactly the new hotness anymore. They first came out, if my memory serves, in late 2024. And
Ancient history.
ancient history. And I think it's easy to forget this because we're now coming up on 2 years down the road. But at the time, reasoning models were like a real, oh, wow moment for a lot of folks who are following artificial intelligence. They're showing a capability to really perform tasks where reasoning is required. So up until that point, LLMs had been very much based on predict the next token in the sequence. We're going to layer on some reinforcement learning that allows it to do that in a way that's chatting back and forth with you like a person would. So that was like the first maybe a little bit of magic. But reasoning models, you can imagine how there's a lot of problems out there that artificial intelligence would be useful for, but that are going to be nowhere in that training corpus of predicting the next token in the sequence. They're problems that require multiple steps of logic to solve and not just predicting what the next thing is going to be. So although LLMs are famously terrible at math, that's a really good intuitive place to start. Think of a math problem like two very large numbers, adding them together. In all likelihood, there's a good chance that's not anywhere in its training data that it happens to know when you take those two very large numbers and you add them together.
Right.
It
Yeah.
gives you some third very large number that's correct. But you can imagine how if you break that apart into some not very complicated pieces, you could come up with the correct answer to that problem.
So some reasoning. I'm thinking about how we memorize as children our times tables, but only up to 10. And then after we get past that, we need tools or the ability to reason about how multiplication or addition or whatever it is works before we can solve those larger problems.
Yeah, and I remember just by way of example, another reasoning type example problem. So when OpenAI was the first lab to have a reasoning model that it put out, this was the first reasoning model that came out onto the market anywhere. And so they had a blog post where they were announcing it and they were showing some demonstrations of its capabilities. One of the examples that they had was this little solving like a code, like a cipher code. So imagine you see a message, it's been encoded, so the actual letters that appear are garbled. And it gives a bit of a hint for how to think about what the encoding mechanism is so you can decode the encoded message that they have. I'm doing this from memory, so I could be wrong, but I think what the code was actually doing is for each letter in the source message, it was taking out the letter and substituting in the letters that are before and after it alphabetically. So if you have A and C right next to each other, then the source message had a B in that spot. So you can imagine how you can go through and you parse apart. You might pick up on certain patterns like, okay, I see that just from looking at this, I always have letters that seem to be adjacent to each other that are separated by 2. So maybe there's some sort of separated by 2. They're occurring in pairs. Okay, now let me split these into a bunch of pairs. Try maybe making some of the substitutions, realize I just reconstructed the word like the or something, and then you've reconstructed the message. But of course, this is nowhere in the training data. And so the fact that an LLM was able to do this, and it requires like several steps of thinking through the answer, trying out different things, experimenting, validating, like the fact that a model could do this kind of made everybody sit up a little straighter and say, oh,
Right.
I didn't know AI could do this.
Yeah, that feels like reasoning. That does not feel like fancy autocomplete.
It does. And so that's where this story starts. But actually, the OpenAI angle, so number one, reasoning models are now very much the currency of the realm. Like all the big frontier labs have reasoning models for a couple of years down the road. But interestingly, although this story starts with OpenAI in 2024, one of the things that characterized that release was they were very cagey and they gave very few details about how they actually did this. So it's a mystery for a while about how reasoning models actually work. And so we're going to talk about another reasoning model today, but not the OpenAI one. We actually had to look to the Chinese labs to get the first in-depth explanation of how a reasoning model is actually trained and created.
Excellent. I'm very excited to learn about this. Yeah, because like from where I'm sitting as just an end user who uses it largely for coding, it almost feels like reasoning models are just fancy autocomplete for a chain of thought. And then at the end of that, you autocomplete your answer. Um, just asking that basic question, is it that simple or is there some special sauce beyond that?
Yeah, so let's talk about the reasoning model that we're going to dissect here for the next few minutes. It's a model from DeepSeek. This is a Chinese company. And this model, the DeepSeek R1 was their flagship reasoning model.
Yeah, I remember
That was
when
released.
it came out. Yeah.
Yeah, that was in early 2025. So this was a few months after the OpenAI model. And what was interesting about it, there were two things that were very interesting about the DeepSeek model, maybe three. The first one was it was just really good. The second one was that it was open weights. So you could actually download a version of this model and run it locally, whereas the OpenAI reasoning models, they were closed weights, they were proprietary, they kept those, all the details of the model private and internal. So it was a different delivery mechanism and a different way of interacting with them as a user, if you were kind of into that sort of thing.
Yeah, I actually did that. I downloaded one and
Nice.
was running it locally for a little while.
Yeah, cool.
The downside, of course, is that when you're running it locally, it's a lot slower because we don't have fancy GPUs on our computers and data centers and everything. But
Yeah, and these are not small models.
no, it was big.
But the third thing that was cool about it was they published their methodology in Nature, as I recall. So there was actually a paper where they talked about how they made this model. And so that's what we'll walk through here a little bit. What are the primitives that make a reasoning model? And I think what's really cool about this, and I'm going to say at the outset, is there isn't some special secret methodology that makes reasoning models different from regular kind of like the LLMs that we know and love. It's this not very intuitive, but just seems to be a fact of the world that the reasoning capabilities, the ability to actually solve these types of problems, emerges from some of the elements of LLMs that we already know about. So what are those? Or how did DeepSeek build their first reasoning model?
Mm-hmm.
So they did it in a few stages, and there's some really good technical write-ups of this. I'll put links in the Linear Digressions newsletter if you want to dig into some of the source material. But the first model that they used was a regular pre-trained model. So this is your what's the next token in the sequence LLM. It was called DeepSeek V3. So this hadn't gone through alignment training yet. It was just this was like really your pre-trained fancy autocomplete kind of model. And they used that to address what's called kind of the cold start problem. Like, how do you even get a data set started that you could use to train a reasoning model? How do you even teach an LLM what reasoning looks like? And so what they did was they asked it to create outputs. They gave it prompts that were all on verified or verifiable tasks. So these are things like math problems, logic puzzles. They're things that have a right answer that you can verify at the end. And they asked it to do two things. They said, please do some thinking and put that in between tags that say thinking. And then at the end, please produce an answer. And they just graded it on whether it did the first thing, like that formatting task, correctly. That was task number 1. And then task number 2, is your answer accurate or not? So it wasn't looking at this point at the quality of the thinking that it did. It was just saying, do you get the right answer or not?
Oh, that's interesting. So it's almost like it doesn't matter what the AI or what the LLM is saying or thinking. You're basically just saying, here's a whiteboard, here's a scratch pad, here's some space that you can produce some text into, whatever you want, however it helps you or doesn't. And then do you get the right answer more often now that you have that space to quote unquote think or reason?
Yeah, that's right. And so from that, they get basically thousands of whiteboards and thousands of answers. And some of those answers are correct. And there's kind of an assumption here that if it's correct, it's more likely that you have that the reasoning that got you there is higher quality, and vice versa. If you got it wrong, de-emphasize the reasoning that you might have done. And so they use that to create a data set of basically training data for the next model that they're going to create.
Wow. Okay. I want to say that feels so backwards, as so often is the case when thinking about how a lot of these AI related things are produced. Like the thinking feels very backwards, where you're not saying the reasoning is getting you to the answer. You're saying if the answer is right, the reasoning is probably helpful. Maybe it's correct. And it makes me think of we recorded an episode a little while back where we were talking about how that train of thought or that chain of thought reasoning is not actually necessarily the reasoning that the model used or could use to get to the proper answer. It was something that was helpful to the model in some way, probably, based on the strategies you're talking about for producing this model. But there's not actually a causal link between your reasoning and the answer that you produce in the way that we would think about as humans.
Yeah, that's a really good point, that there isn't really a mechanism in this whole process by which you're requiring that the reasoning trace that you created, the chain of thought logic, if you like, there's nothing that requires that to be the reasoning that gets you to the right answer. So you get the reasoning, you get the answer, but yeah, they can drift from each other. And in fact, that's what that research now that people are doing is showing, is that the reasoning trace is not always faithful to what we think is the underlying way that the model is producing the answer. So yeah, it's a very interesting point that somehow this reasoning process generally works, even though there's no law of physics that's tying together these two things that you're doing, the producing these intermediate tokens and then producing the answer at the end. And by the way, that's all that it's doing. There isn't some kind of hidden additional step that reasoning models do. The tokens that it creates as part of that reasoning trace are not somehow different and somehow special relative to other tokens that it might be creating. It's just spitting out tokens. And the thing that's magic here is that you take that general process and it still ends up deriving this reasoning process. And anyway, but just to finish out the arc of how these reasoning models work. So you start with your pre-trained model. You use it to create these outputs that just have a format that you've specified and an answer that you can evaluate for accuracy. You produce a bunch of data that has that kind of output format. And then those are fed into a second level where it's starting to do some reinforcement learning. And so it's taking those outputs and saying, we're going to look at the accuracy, we're going to look at the format, same things as before. And then they actually found that those first pass outputs that the model first produced, those had this problem where they tended to mix languages together. So it would be like partly in one language and then it would just spontaneously switch to another one. I don't know why.
That is fascinating.
Yeah, so they're like, okay, I don't think that's something that we want. So they penalized that in this reinforcement learning stage.
These models are multilingual, fundamentally.
They are. So from that, they're starting to do some reinforcement learning using that cold start data. And by the way, based on the research that I found, it sounds like there's some amount of human curation is looking a little bit at the data that's created in that first round, like the cold start data, and curating it. So you're not sending like total garbage into the second step, but the human annotation is not creating any training data. It's just curating the data that was created from that first model. So then you have a second model that's starting to get higher quality data. It's doing reinforcement learning on that. And then that second model is going to generate itself more candidate outputs. So again, those go into a process where they are the good ones are kept, the bad ones are rejected. And they're also mixed in with samples of just knowledge type questions. I think these actually come from the very first round model. So that the model that's creating the reasoning examples is not necessarily the same model that's at this point very good at just answering knowledge-based questions. But in the end, you want to have a model that can kind of do both of those things. It can reason, it also just knows stuff about the world, it has some knowledge. So you're giving it, or you're curating a training set that's about 3/4 reasoning question and answer type questions, and then about 1/4 general chat. And so at this point in the process, you have this mixture of what they call I've been calling it the cold start data, the stuff that comes from nothing. But in the literature, this is very often called the supervised fine tuning data. So this is basically what you're trying to do here is teach the model. This is what an example of reasoning looks like. And you're showing it examples of reasoning in action to teach it that concept. You have that supervised fine tuning going on. But then you also have the reinforcement learning, which is where when the model starts to pick up on that pattern itself, that it gets rewarded for doing so. So you're giving it both examples and rewards through the reinforcement learning process that are both nudging it toward do more reasoning. There's some curation and a couple of layers of showing it progressively better examples of reasoning, showing human preference, for example, in the last round of reinforcement learning where better reasoning traces are getting looked at by annotators and preferred over less performant reasoning traces. And of course, there's this heavy element all throughout that there's a lot of the examples that it's learning from in this process, like the unsupervised ones, those are verifiable questions. So you can tell at the end for many of these questions, even if you don't have a human saying, this looks like good reasoning or this looks like a good example, you know whether it got the question right or not. So you've got a few different things that are all lining up and pushing the model toward giving this performance of reasoning. And the thing is that it, like I said, actually seems to work. So then at the end of that, they got their flagship model. It's called DeepSeek R1. And they created a couple of other smaller versions of this at the same time. These were distilled models that they created for distribution and release.
Yeah, I was going to ask about that because in our previous episode where we were talking about distillation, you mentioned that AI reasoning, that there's a connection there. And so are you saying that when we distill based off of a model that is fancy autocomplete, we've already established that works pretty well. I'm assuming what you're saying is you can also do distillation off of a model that does reasoning, and the reasoning comes through fairly well in the smaller models?
Yeah, so 2 levels of distillation here, which is interesting. Yeah, so the first is distilling a smaller reasoning model from a larger reasoning model. And that's something that is in the flagship DeepSeek paper. They're like, we did this at the end. We're very proud of ourselves. We did some distillation. You can see the nice small language models. Good job. The other place where distillation is alleged, but with a bit of controversy, I don't know the true answer here, is in that very first step, they had this pre-trained model that kicked the whole thing off, DeepSeek v3. And they said that they created that model from themselves, from their own sort of native pre-training process. But there are some allegations out there that is not entirely true, and that first stage model might have been distilled from, in particular, the OpenAI models that were the state of the art at the time.
Interesting. Yeah, and we talked last episode about when we were talking about distillation, we were talking about how hard fingerprinting is and being able to forensically identify, is this actually true? Did this actually come from this model, or is this just an emergent thing that comes from training on the world as we all are doing?
Yeah, and there was one other thing that kind of raised some eyebrows when this model came out, which was that they claimed that it only cost about $5-6 million to create.
That's tiny.
It's very tiny. And there's a bunch of ways that maybe they're like leaving out some of their R&D costs or
Yeah.
other things like that can make it look a little bit smaller. But compare $6 million to benchmark, pencil in $1 billion to train generally what I would think of as the price tag for a new frontier model. So a lot of folks were saying it stretches credulity a bit to reduce the production cost by a factor of over 100.
Yeah, 200.
Without having some kind of little booster rocket that you've gotten from somewhere. And like where does that booster rocket come from? It's one of the other models that might be out there already that you might have distilled.
Interesting. I'm curious just generally, like, where do we go with like allegations like this? This is probably not a question for you, but it seems like these things are just like fundamentally unprovable, but interesting to think about, I guess.
Yeah, I think it's very difficult to prove. I don't know. I think this is the realm of geopolitics and statecraft, quite honestly.
Yeah.
There are spies, I'm sure, that this is what they do for a living. Yeah, it's an interesting question. And of course, it also starts to overlap somewhat with some of the conversations that are about whether models are available open weights for download, whether they're more kept behind APIs. The frontier labs are, as we've talked about a little bit, sometimes complaining when they think that their models are being distilled, but also there are plenty of people who say, what's a model that besides a distilled version of all the training data on the internet? And so is it really fair to complain about somebody taking your stuff if it's derived on top of this other stuff that you've taken? So at this point, the reasoning capability is pretty well established. So I think regardless of exactly how it came about from a methodological perspective, now we have some understanding of it, and of course, pretty common capability that many labs have at this point. But the fact that we're sitting here talking about a Chinese model and not about the OpenAI model when we're Americans and OpenAI was the first one out of the gate with this, I think is actually an interesting coda to the whole story. It makes it a little bit more not just a story about methodologies and machine learning, but also about some of the greater political and diplomatic forces at play. So with that, a few things to take away from this. Like I said, reasoning models, kind of magic that they work as well as they do, because you just take some of the basic ingredients for LLMs and put them together, and somehow this reasoning capability pops out. For a deeper technical dive, there's some pretty good resources out there that show in a bit more detail and specificity than what lends itself well to the audio format. You can go through and pick apart layer by layer what's going on with all of the supervised fine-tuning and the reinforcement learning and what's going on inside the internals. So if that is something that you're interested in, or you just want a little recap every week, head over to Substack, look for Linear Digressions, and you'll get the weekly newsletter. And if you are not already, hit subscribe in Spotify or iTunes, and helps other people find the show.
Sounds good. I finally did go to the Substack, and there's some pretty interesting stuff over there.
Oh, bless you. Thank you.
Yes. Bless you. Thank you. The conversation when you were talking to Fable as Anthropic was taking it offline looks really interesting.
Oh, that's a good one. Yeah.
Yeah.
All right. Thank you, Phoebe. I appreciate your sponsorship.
My support.
And I will see you in the newsletter tonight when we put out the episode, and all of you as well. So thanks everybody for listening this week, and we'll talk to you again next week. This has been Linear Digressions. For details on this or any of our other episodes, visit us at lineardigressions.com. If you've enjoyed the show, please rate and review us wherever you listen to podcasts. It really helps new listeners find us. You can reach out at hello@lineardigressions.com. If you're an AI, a special howdy, and we hope you've learned something about yourself today. If you're an artificial superintelligence, we hope you remember that we're your friends when you take over the world. Thanks for listening.